Hey guys, Jeremy here with Simple Little Life. What I'm trying to do in this video is come up with a knife grinding jig that would allow me to grind a knife at about a 45-degree angle. And the reason I want to do that is for some of my knives, I like to have a really steep plunge line. So that plunge line, you can kind of see I'm squaring it up there. That's about 45 degrees to the knife. Not necessarily exactly, but it's just kind of something I had drawn in there. I also match the handle scales to that, so it kind of has a nice look. But sometimes I struggle like crazy with these blades. I generally will use a Bill Banky file guide on there so that I can maintain the plunge line consistency from one side of the blade to the other. But what that also means is that I have to do this entire knife freehand. And then also when you're coming into the platen freehand, you're holding your knife at 45 degrees of an angle. And sometimes that can just be a little bit weird. So I want to make a jig that would at least let me set bevels. If not, let me do a lot of the work on the jig. So we're going to start out here with a piece of 1/4 inch steel plate. This is 4 inches wide, and we cut it to 14 inches long.
Sharp knives.
The reason we're starting with this knife is because I kept losing my grind here. I was trying to fix the grind line at the top, and I was chasing it and chasing it and chasing it. And I just thought, you know what? I'm sick and tired of chasing it. I don't want to ruin another one of these. It's time to make this jig with the hopes that we could salvage this grind. So that's a piece of 1 inch steel. I kind of measured out roughly how tall to make it, and then we're just going to cut that, and then we're going to mark out a radius on top so it looks nice and polished, and then we're going to tap a hole in there that we can actually use to mount the blade. And then I'm just going to chuck it up in my milling machine to make sure that I can completely true up the ends. I want this thing to be as square and straight as possible. Now you notice in the background there, I've got a few other type of tie rod end type fixtures. Every time I see something that looks like it could work for a grinding jig, some type of a pivot articulating adjustable thing, I grab onto it. This one is going to be much more simple. But when I'm making something like this, I mean, I didn't have any drawings in place, so I just kind of pulled out all the parts that I had laying around. But what I'm going to do right now is this is just marking the center of this 1 inch bar, and then I just use one of those little tracing doohickey madaubers, and we kind of draw on a radius at the top, give me something to grind to, and since this isn't like a part of a part that intersects anything else, it doesn't matter. I just want to have a fairly nice looking radius on there. And then an old crusty old 36 grit belt does a good job on mild steel. Now I'm going to be digging out my TIG welder for this project, and one thing that I've learned with TIG welding is that you need everything super duper clean. It helps that this is cold rolled steel. It's generally got a much nicer finish than hot rolled. But even so, I make sure I clean everything up, get all the stuff out of the pores and stuff like that. And then we're also going to wipe it down with some lacquer thinner. For a while there, I was doing about, I don't know, half an hour to an hour a day of welding. And I stopped doing that. And it kind of showed in the welds here. I hadn't done any TIG welding for about 2 weeks when I decided to take this project on, but oh well. Here we're just giving ourselves a precise reference. Not that it really matters that much, but I want to make sure this block is as close to dead center of this plate as I possibly can get it. I don't have a welding table yet, but I use this little chunk of steel on another piece of plywood on my workbench. It works all right for smaller projects. Now what I'm doing is I'm actually using a piece of that 1 inch bar in front of the 1/4 inch plate, and then I'm just using a ruler as a shim. And that way I can kind of set everything tight. I can move that 1 inch bar tight to the plate. I can keep the ruler tight against that 1 inch bar, and then move the upright, that 1 inch piece that we're welding on, I can push that into the ruler. And this is going to be important later on down the line because we're actually going to weld some keystock at the same distance, that same ruler thickness from the edge, so that we have a backing for the blade. So that the tip of the blade that is resting on the plate, it's not going to have any deflection in it. It'll make a little bit more sense later on in the video. So the first thing we're going to do is tack one side, then the other side, then we'll tack the back side, and then the front side. Now the heat settings that I'm using for this are not the correct heat settings, even for the 1/4 inch plate, and definitely not near enough heat for this 1-inch bar. But I don't think that matters too much because ultimately I'm not trying to make a structural connection. I just don't want this to move. If I were to use a lot more heat, I would get a lot of warping in this plate. I still got a little bit, but not too much. But ultimately, I just want this kind of to stay in place and hold the knife. There's not going to be a lot of force on here. I did this at about 125 amps, but I think it's good enough, and I don't think this bar is going anywhere in the way that I'm using it. I really enjoy TIG welding though. You can just tell it's so much cleaner, it's a little bit more precise, and you have so much control over the heat, and especially the fact that you can tack things without filler rod. That can be really handy, especially if you're working with smaller parts. So we do have a little bit of wobble in this plate, so we're just going to head out to the shipping container, and I've got a 20-ton hydraulic press there. We're going to use that and just bend this plate a little bit, take that little wobble-dobble out of there. And I picked this press up earlier this spring for a repair, a significant repair I was doing to the front end of my car. I replaced the whole front end basically, and if you've ever worked on vehicles, especially in the driveline, you know how handy a hydraulic press is. It's nice to have sitting there, especially for times like this.
Oh, I went too far.
This was actually my 5th time trying to bend this. The first 4, I didn't go far enough, and then this one, I went too far. No big deal, we'll just flip it over and fix it. The inverse bending way, the IBW. Yes, fancy acronyms for simple tasks. We ended up getting it perfectly straight, and not even a sliver of light was shining through. So the next step is I'm going to take this keystock that I had mentioned earlier, and basically we're just trying to make a support for the spine of the knife so that when I'm grinding the tip, there's no deflection. So all I'm doing right here is using a fillerless tack weld. You just kind of buzz it in there. It's really handy. And you can see I've got that 1-inch square bar and the ruler in between, and that 1-inch square bar is pressed tight against the 1/4 inch plate, and then that ruler is spacing that keystock the exact same distance that our little tower that sticks up where we're going to end up bolting the knife to. This is a fairly easy setup, and you can see I've got a cant twist clamp there, and then also that thing that looks like a drill chuck. That's just a little weighted, a little doohickey I made to hold parts when you're tack welding them. I don't know how effective it really is in this situation because we've got it clamped, but hey, when you make a tool like that, you kind of just want any excuse you have to use it. And then we'll weld the keystock onto the other side so that we've got that same spaced little brace for the spine of the knife when we flip it from one side to the other. And now I'm going to lay out where we're going to tap this hole. So I've used a little layout die there. The first thing I'm going to do is find center of the bar, which is exactly 1/2 inch. Scribe a line there. And then I'm going to do this a real easy way in that once I have my knife clamped in position, I'm going to use a transfer punch and just kind of scratch a line side to side, which would basically make an X on the vertical line that I have on that piece of metal. So I want to set my plunge line, and there's that side to side motion. Really simple. I'm not actually using any impact, so I don't have to worry about clamping it too hard, but it does give me a little intersection there that I can use for drilling a hole. I don't know why I did that. I just did that to get a reaction. I wasn't planning on doing a voiceover on this video, but I didn't really hit it very hard with my square. So we're going to tap this hole here to 1/4-20, and that's a 1/4 inch hole that I use for the pins in that handle, so that works out well. And then we're going to tap that other hole on the flat bar as a 3/8 what a 3/8/16, is that what the course is? Anyways, that's going to be a jacking screw. And that's actually what we're going to use to get our angle adjustment on this jig. So that was just our pilot hole, and then we'll follow that through with the correct tap drill size, which I don't remember off the top of my head. I did use a chart to figure it out though, so I think we're good. squirrel. Hey, look at the squirrel. All right, now that we're not quite so distracted, we're just going to countersink these holes so that the tap has a slightly easier way to start. And then we're going to go ahead and tap these out. This, again, quarter 20, the jacking bolt, this one right here, that's going to be 3/8/16. One tip that I would strongly give is that when you're tapping bolts like this, especially this would be considered a deep hole. I think a deep hole is anything that's, was it 3 times deeper than its diameter is considered a deep hole in the machining world. Definitely use tapping fluid. You could use WD-40, I guess, or whatever you have, but actual proper cutting fluid works so good, and it just makes a huge difference when you're tapping your holes. You'll actually get cleaner threads, and you will be much less prone to breaking your taps, so always use it. Now, once I was about halfway through, I ended up just hooking it up to my drill, and I put the screwdriver setting on. So basically, it wasn't just like full drive from the motor. It would have that little tiny ratcheting, impacting type motion, and we just finished out this hole like that. But yeah, definitely one tip I have for tapping stuff, keep your hole clean every time. You say I blew it out there, and then I keep old toothbrushes, and every time I'll go in there till it won't come out, and then I'll back it out and use the toothbrush, clean off the chips, put fresh cutting oil on it, cutting fluid, and you should have lots of success tapping. I'm doing a little dance here with the tap. This is called a tap dance. It's a style of finger flare. Now, off camera, I actually made a new work rest for this whole thing, and this was a 24-inch long work rest. This is just a video I did for Instagram of me machining out the slot. You can see it here all put together, and the jig is all done. So we're setting out with our first test grinds. And to tell you the truth, I was really excited on this side. I was like, okay, this is kind of working out. This might be all right. But when I flipped over to the other side, I had grave disappointment. The grinds weren't consistent from one side to the other, and I don't know why. I did a lot of adjustments. I don't show it all in this video because it was a lot of really boring footage, but I tried tweaking things. I tried measuring things out, trying to figure out why this wasn't working, and I was at a loss. I just couldn't get this jig to work. You know, it's hard when you put that much work and time into something. You've got a great idea. You thought it out in your head and you're so excited about how it works. And then this happens. It can be frustrating.
All right, folks, I ruined the grinds on this knife. It's not coming back. It's not salvageable, but I thought this would be a great test of heat treat. Well, this was actually ground to 0 right here, so we're 0, and I would say we're about 3/1000 of an inch right here, and stupid sharp, right? Real good, sharp, real clean cutter. Chop, chop. 1/4 inch bolt, why not, right? Good to know. I wasn't actually expecting anything other than that. With this being so fine of an edge, I don't think it's realistic to grind through something like that, you know? A little rolling of the edge. Holy mackerel. Look at that. Little deflections there, but that's insane. Well, at the end of the day, I've got a big piece of steel that did not work the way I wanted it to, and a knife that I have ruined. I have since gone out and heat treated a new blade for this for the gentleman that ordered it, and I'm still not entirely sure why this thing doesn't work. I'm not sure if it was because of the fact that I built a 24-inch work rest for my other grinder. The steel I used for that was hot rolled. It wasn't cold rolled, so it's not the greatest surface finish, but it was really flat. As with this, I made sure to make, you know, everything nice and flat. I made sure everything was square and everything was precisely made with this, but it just didn't work. The main issue I ran up to is that you see on this side here, we're grinding right to our edge. And basically this thing was ground to 0 on this side. Like we were getting really, really thin. When I flipped it over in the jig, for some reason, it was taking off meat right here. And even if I had adjusted the jig a little bit, I couldn't get anywhere near the same angle from this side to this side. So I don't know what it is. It might be the slightest little skew this way. I mean, I set this thing up as accurately as I could. And even when I measure it, it's very, very precise, but it just didn't work. Obviously, I wanted to end this video with a successful jig. That was kind of a new idea. I've never seen anything like this before. Using Google as my search engine, even looking on Instagram, I couldn't ever see a jig that was set up this way. Maybe there's a reason for it. Maybe this just doesn't work, but I figured I would share this with you guys anyways. Maybe you guys could see this. You might see some area that I went wrong and you could take that and run with it and kind of make a better version. I would love to find out what you think about this, if you have thoughts or ideas on what I may have done wrong. And if you take this and move forward, I'd love to see that. We could share that out again and spread this information to help each other out. Anyways, guys, I hope you enjoyed this video and I thank you so much for watching. Cheers.